Welcome students to our first lecture video on numerical summaries. In today's video, we're going to be talking about measures of central tendency. Some of these might already be familiar to you. Now, don't get intimidated by this slide. There's a lot on here, but you've already heard of these measures before, I'm sure. So the first one that's on this slide is the mean. That is also known as the average. So if you've ever heard either one of those terms, that's where you add up all the data values that you have, divide by the number of data values you have, and that will give you a measure of center. Now, this measure is really useful when the frequency distribution is symmetric, and it's incredibly useful when we get into inferential statistics. So be really comfortable and familiar with the mean. It's also the interpretation as a center of gravity. Imagine if you're sitting on a seesaw. In order to balance a bunch of individuals on a seesaw, you find that middle point that would be the pivot. And depending on the weight of each of the individuals on the seesaw, you might have to move them closer or further away from the pivot to get to balance. So that's sort of what's happening here. We're finding the place to put that pivot so that the seesaw doesn't fall to one side. Now, one of the other measures is the median. The median is in the middle of the data set, and it is in fact the middle of the data, no matter what the data is. So what that means is no matter whether you have really, really high value or really, really low value, those will get chopped off of either end as you work your way towards the middle. And it directly divides the bottom number of data from the top number of data. So if you had, let's say, 100 data, you know that somewhere around 50 would be a middle. So the lower part would be on one side and the higher numbers would be on the other. We will do several examples of this. And that is really useful when the data is skewed left or right, because it removes the really, really large unexpected values or the really, really small unexpected values. Now, the other measure of center listed here is the mode, and that is the most frequent. So it's the one that shows up in the data the most. That one's not really useful typically for numeric data, but is very useful for qualitative because it's the only measure of center you have for qualitative data. So let's dive right in. We're going to discuss the mode first. So again, the mode is the most frequent. So if you have this data set 1, 9, 9, 11, and 20, which one shows up the most? 9. So the mode is very easy to spot. In graphical displays, it'll be the highest frequency value. So that relates back to the material that we did in the videos prior. Now, remember I said it's also useful for qualitative data. So let's suppose that we have this as the list of preferred pets by people we survey. And what you might notice here is we have 2 for dog. So that seems to be the most, but there's a tie. There's also 2 for cat. In this instance, both dog and cat are the mode. So you can have 2 modes, or you could have even more than 2 modes. But it's the highest value for the data, the most times that it shows up. And if there's a tie, that one gets listed as well. Be very careful in Excel when you do this because it may only give you 1 and you won't know that there's another one that exists. So mode is sort of easier to graph or to spot with your eye, especially after you sort the data. Moving on to the median. So I said the median is in the middle of the data. So what that means is if I count from one side over and I move the same on the other side over, then wherever I land, that's the middle of this data set. So I moved 3 from the left-hand side, I moved 3 from the right-hand side, and I ended up in the same center. So in this case, 9 is the median. This works really well for odd data. It gets a little tricky when there's even, because if I do the same game and move over from one side and then the other, I end up in a blank spot. Now that blank spot can still exist and we'll still divide the data in half. As you can see, there are 3 data values to the left and 3 to the right. So it cuts it in half. So what we do is we average the two values in the middle. So if we take the 9 and 11, right in between the two of them is 10. So in this case, the value that is the median would be 10. Now the mean takes a little bit more work in terms of arithmetic. Now these formulas look terribly scary, I know. They're a little bit Greek, and that's by design. So one thing that's really important to notice now is when we're talking about population numerical summaries, we're talking about parameters. You might remember that from Unit 1. So when we're talking about parameters, they are represented by Greek letters to indicate that they are values for the population. That'll be really important again in inferential statistics. So remember, population, parameter, Greek letters. In contrast, if we're looking at the sample mean, the sample numerical summary, it's a statistic and it's written as X bar. So X with a little line over it. But both of these are calculated the same way. The capital N is the number in the population. The tiny n is the number in the sample. But either way you slice it, these both get calculated the same way. You add up all of the values in your data set and you divide by the number in your data set. So in this case, we're going to add up 1 plus 9 plus 9 plus 11 plus 20. That'll give us a grand total of 50. And we're going to divide all of that by 5 because there are 5 data points. Therefore, the mean in this case would be 10. Now, here's the really great news. That seemed like a lot of work and a lot of computation. There are 2 magic formulas. If you are in Microsoft Excel, you will type in equal average, and within the parentheses, you'll put the cells that your data is in. I will provide examples of that in a workbook. If you are using the R program, you'll create a list of data. So you'll enter the data first in a list, and then all you have to do is type mean parenthesis data if you've named your data data. I will also give an example of that. Both of those are much quicker than doing it by hand. So we are really excited to have technology in this class. Unfortunately, when the data come in a table format, the process becomes a little more difficult. But I'm going to use an example we're familiar with from before that has the data laid out and see how the table data relates to what we just did in calculating the mean. So first, I'm going to sort the data just so we can see how many of each value there are. And this is going to be really important when we get to the next step. So in terms of measures of center, the mode, again, is just really easy to find when you have the data set listed. So in this case, 8 shows up the most often, so it is the mode. Now, to find the median, again, we look for the center of the data, and we can do this pretty quickly. There are 40 data points in total. If we divide that by 2, that gives us 20. So somewhere around the 20th value is where the median would be. But since it's even, there'll be 20 on one side and 20 on the other. Remember, if it's even, there is no center. So we're going to have to actually find the center. So we have the 2 8s in the middle. And if we add them and divide by 2, it's going to be 8. Now, this should not be a surprise, because what value would be between 8 and 8? Well, there is no value. So the answer has to be 8. Now the mean is going to take a lot more effort because now there are 40 values. So this might take forever. Here we go. So we add it all up. I'm not going to read that, but you know all 40 data values are on the top, all added together. That equals 315. And on the bottom, there are 40 total. So we divide by 40. The mean is 7.875. Now that was a lot of work. It's much easier in Excel. But now imagine, if you will, we have it in a table instead. Now this is okay because this is what we just did. If you look at the 3 people waiting, there were 2 of those. So that top line says 3 plus 3. There are the 2 that we had in the raw data. Here it is in the table. maybe you're going to notice something very soon. And then we have 4 plus 4 plus 4. And there were 3 of them. That looks like 4 times 3. And then 5 plus 5 plus 5. That means we have 3 5s. So this sort of looks like multiplication now instead of addition if we use a table. What do I mean? Well, let's go to the next slide. If we look, we have 3 times 2, 4 times 3. That's the exact same thing we just had, but now it looks like what we have in the table. So now there's a relationship here. Again, the formula looks very scary, but x sub I is just the data value, in this case, 3 through 14. And the f, the frequency, is how many times it shows up. And if you put 2 values next to each other, it just means multiply. So let's put it in the table, and then we can do it in Excel, and it'll be much easier. So in the table, this is what it looks like. It's just a multiplication problem. 3 times 2 is 6. 4 times 3 is 12. So if we want to get at the mean, all we have to do is multiply each data value by the number of times it shows up. And that'll give us the sum of all of the frequencies for the data values. So here we have the sum of all the data values, 315 and 40. So what we can do is we just divide the 315 by the 40. The total of the data values divided by the total number of values. And again, that just gives us 7.875. So it's not horrible. It's now multiplication. Now what's interesting is, where is that measure of center? Well, the median was at 8. The mean was pretty close to 8. 7.875 is very close to 8. That sort of tells you that this distribution is symmetric. And that's really useful, again, when we get to inferential statistics. Now, I'm going to pause here and let you think about this a little bit. I'm going to fly through this example a little faster, but here we have continuous numerical data, which is fine. It's still quantitative. So the mode is the most frequent. This one does have a mode. 2 shows up a lot. So that would be the mode. We also do have a middle. There are 50 states, which means if we divide that by 2, there would be 25 on each side. So we want to look at 25 and 26 down here at the bottom. And those are 1.25 and 1.339. So if we divide those 2 by 2, we find exactly what would be between the 2. So we will say 1.29 is the median. And moving on, the mean, if we add all of these values up, we would get 71.29. And if we divide by the 50 states, then we'll have 1.43 about. Again, Excel can do this a lot quicker, and I'll let you play with that. All you need is equal average, parenthesis, and then all of the cells that this data would be found in. Now, again, we're going to compare the two. So we have the median and the mean. So when we compare these two, you'll see that the mean got pulled over to the right, away from the median. So whichever direction the mean gets pulled means there's a value over there that's tugging on it. And we know in this case that that value is 4.35. It's a cigarette tax rate in New York. So New York pulled the mean away from where the median is. So that means that this would be a distribution that is skewed to the right. Now remember that table data that we did earlier? That became much easier when we realized it was just multiplication. Except now we don't know what the raw data values are. We only know the interval that it's between. So we know in here, there are 897 between 200 and 300. The way we fix this problem is we just pretend that all of those values are right in the middle of the interval. And that would be a midpoint. So let me ask you a pop quiz question to think about. What number is directly in the middle of 200 and 300? If you said 250, you are correct. So if we use the midpoint for all of these, we can do what we did last time and just multiply. So let's do that. So here, if you add the 200 and the 300, you would get 500. Divide it by 2, and magically you get your 250. And then we'll just do the multiplication like we did last time. So let's fill this out. It again looks very complicated and very scary. But here we just have the class midpoint. That 250 is going to be our data value. And we're going to say there are 897 of those to add. It's much easier to multiply. So what we're going to do is we're going to take 250, multiply it by 897, and we get a really ridiculously big number. And they get bigger as you go down. Again, Excel is really great to have in this class. It'll do all these calculations for you if you set up the formula. Now we have the total of all our data values and the total of our frequency, which is the total number of data values we have. So now it's just division. So that means that we have 528 as our mean, which falls right in the middle of this graph. Not surprising, it looks very symmetric. So the middle would likely be in the middle. I'm just going to flash this practice problem up here for you. It is coming up in your Excel workbook. So look forward to that in your next workbook. Last but certainly not least, if we look at these graphs, let's try to figure out which one belongs to which graph label. So I'm going to pause the video here, and you can take a time to, you pause the video here and take a moment to see if you can figure out which graph goes with which. And then join me when you're done. Okay, welcome back. So let's start looking at these values. So if the mean and the median are the same value, that means they overlap. That means it might be symmetric. So for the first graph, we're looking for something symmetric that has a middle that looks like it would be 42. Now, the first one, the middle looks too low. The next one looks skewed. B looks a little skewed. C looks skewed as well. But D looks pretty symmetric and looks like 40 would be in that middle pier. And of course, that one matches. So let's try the next one. If the mean is less than the median, that means it got pulled to the left. There was a lower value that tugged on it. So that would probably be a skewed left situation. So we're looking at likely C. And it is. Now, for graph number 3, the mean is bigger than the median. So that means that's getting pulled to the right. The mean got pulled to the right, so it must be skewed right. So that, of course, must be B. And now, since the mean and median, 31, 32, are pretty similar, then that will be the measure of center, and it should be symmetric. So we're looking at A. I hope you had fun with that matching game, and it helped you understand how the mean and median help you know the shape of your histogram as well. If you have any questions, let me know, and enjoy using Excel to do the hard calculations for you. I know I like it.